Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Algebra, Lesson 5-6, Inverse Variation. So we want to solve inverse variations and compare direct variation and inverse variation. Okay, so here are our key concepts. In our previous section we worked with direct variation. So here, this is a case of direct variation. So let's look at this first. In this case, y varies directly with x. Y is directly proportional to x, and the ratio y over x is constant. Another way of thinking about this, as x increases, so does y. So they're both increasing at a steady, constant rate, basically. Okay. When I go over to this side, this is an example of the graph of an inverse variation. In this case, y varies inversely with x. So y is inversely proportional to x. The product xy is constant. What you might notice in this graph is that as x increases, y decreases. Okay? So one is increasing, one is decreasing. Whereas with direct variation, they are both, each variable increases proportionally. An equation in the form xy equals k, or y equals k over x, where k is not 0, is an inverse variation. The constant of variation is k. Okay. So we're going to examine how things look a little bit differently with the inverse variation and compared to direct variation. Well, let's go through some examples. The points 5, 6, and 3y are two pairs on the graph of an inverse variation. Find the missing value. Okay, use the equation y sub 1 times y sub 2 equals x sub 1 y sub 2, since you know the coordinates but not the constant of variation. Okay, so we're going to do this using the idea that the product xy is equal to k. Since we don't know what k is, we'll use the two different values, two different coordinates. Okay, so x sub 1 is 5, y sub 1 is 6, x sub 2 is 3, and we don't know what y sub 2 is. So 5 for x1, 6 for x sub 2, and 6 for x sub 1, and 3 for x sub 2. 5 times 6 is 30, when I simplify, equals 3y sub 2. We're going to simplify by dividing by 3 each side. So y sub 2 is 10. The missing value is 10. The point 310 is on the graph of the inverse variation that includes the point 5, 6. Okay, so that's relatively straightforward, just using the fact that if they are on the same graph of an inverse variation, the products of their x and y coordinates should be equivalent, and we can solve for a missing value there. Okay. Okie doke. Next side, applying inverse variation to physics. Jeff weighs 130 pounds and is 5 feet from the lever's fulcrum. If Tracy weighs 93 pounds, how far from the fulcrum should she sit in order to balance the lever? So basically what we want to do is to relate a weight of 130 pounds being 5 foot from the fulcrum to the weight of 93 pounds and figuring out how far it needs to be from the fulcrum so that they can balance. Okay, weight and distance vary inversely. Okay, so weight sub 1 is 130 pounds, weight sub 2 is 93 pounds. Let distance 1 equal 5 feet, and distance sub 2 is x feet. It's what we do not know. Okay, so here's what we're going to do. We're going to do weight and distance from sub 1 times weight and distance sub 2. So 130 weight times distance of 5 feet. Weight in sub 2 is 93 pounds. Don't know how far that's going to be. So 130 times 5 is 650 equals 93x. So we're going to do 650 divided by 93x, and this is about 6.98 rounded. So Tracy should sit about 7 feet from the fulcrum to balance the lever. Okay, so again, here's again, we know that weight and distance vary inversely. So this tells us we can use that idea that if they both vary inversely and you're trying to balance means that they should equal. We can use that idea a second time, like we did in example number 1. Okay, here we go. Determining direct or inverse variation. Decide whether each data set represents a direct variation or an inverse variation, then write an equation to model the data. Okay, the values of y seem to vary inversely with the values of x. Okay, so basically what we're saying is that when y is getting large, x is small. When y is small, x is large. So there are inverse variations on there. So I'm going to say the values of y seem to vary inversely with the values of x. Check the product, each product xy, because remember xy is the constant of variation in an inverse variation. Okay, so the product of each of these is 30. So this is an inverse variation, and k equals 30. So the equation is xy equals 30. Because remember again, the general format is xy equals k. Now if we look at this one, 2, 3, 4, 6, 8, 12 are our ordered pairs. The values seem to vary directly. So we're going to check the ratio x over y, because remember in a direct variation, k equals y divided by x. And I think I said x over y. I misspoke. It should be k equals y divided by x. So I'm going to check all of these. In each case, it gives me the same value of 1.5. The ratio x to y is the same for all pairs of data, so this is a direct variation. And k is 1.5. So my equation is y equals 1.5x. In that format when I want to write it that way. Okay. All right. Let me double check this time that I'm not leaving anything out. I believe that's it. You do have quite a few examples and quick checks. Go ahead and have these ready for discussion next time we meet in class. I look forward to seeing you then.